In photography, a shutter is a device that allows light to pass for a determined period of time, exposing photographic film or a light-sensitive electronic sensor to light in order to capture a permanent image of a scene. A shutter can also be used to allow pulses of light to pass outwards, as seen in a movie projector or a signal lamp. Camera shutter. Camera shutters can be fitted in several positions. Leaf shutters are usually fitted within a lens assembly, or more rarely immediately behind or, even more rarely, in front of a lens, and shut off the beam of light where it is narrow. Focal plane shutters are mounted near the focal plane and moved to uncover the film or sensor. Behind the lens shutters were used in some cameras with limited lens interchangeability. Shutters in front of the lens, sometimes simply a lens cap that is removed and replaced for the long exposures required, were used in the early days of photography. Other mechanisms than the dilating aperture and the sliding curtains have been used. Anything which exposes the film to light for a specified time will suffice. The time for which a shutter remains open is determined by a timing mechanism. These were originally pneumatic or clockwork, but since the late 20th century are mostly electronic. Mechanical shutters typically had a time setting, where the shutter opened when the button was pressed and remained open until it was pressed again, bulb where the shutter remained open as long as the button was pressed, and instantaneous exposure, with settings ranging from 30 inches to 1/4000 for the best leaf shutters, faster for focal plane shutters, and more restricted for basic types. The reciprocal of exposure time in seconds is often used for engraving shutter settings. For example, a marking of 250 denotes 1/250. This does not cause confusion in practice. The exposure time and the effective aperture of the lens must together be such as to allow the right amount of light to reach the film or sensor. Additionally, the exposure time must be suitable to handle any motion of the subject. Usually it must be fast enough to freeze rapid motion, unless a controlled degree of motion blur is desired, for example to give a sensation of movement. Most shutters have a flash synchronization switch to trigger a flash, if connected. This was quite a complicated matter with mechanical shutters and flash bulbs which took an appreciable time to reach full brightness, focal plane shutters making this even more difficult. Special flash bulbs were designed which had a prolonged burn, illuminating the scene for the whole time taken by a focal plane shutter slit to move across the film. These problems were essentially solved for non-focal plane shutters with the advent of electronic flash units which fire virtually instantaneously and emit a very short flash. When using a focal plane shutter with a flash, if the shutter is set at its X-sync speed or slower, the whole frame will be exposed when the flash fires. Some electronic flashes can produce a longer pulse compatible with a focal plane shutter operated at much higher shutter speeds. The focal plane shutter will still impart focal plane shutter distortions to a rapidly moving subject. Cinematography uses a rotary disc shutter in movie cameras, a continuously spinning disc which conceals the image with a reflexed mirror during the intermittent motion between frame exposure. The disc then spins to an open section that exposes the next frame of film while it is held by the registration pin. Focal plane shutter. A focal plane shutter is positioned just in front of the film, in the focal plane, and moves an aperture across the film until the full frame has been exposed. Focal plane shutters are usually implemented as a pair of light-tight cloth, metal, or plastic curtains. For shutter speeds slower than a certain point, which depends on the camera, one curtain of the shutter opens, and the other closes after the correct exposure time. At shutter speeds faster than the X-sync speed, the top curtain of the shutter travels across the focal plane, with the second curtain following behind, effectively moving a slit across the focal plane until each part of the film or sensor has been exposed for the correct time. The effective exposure time can be much shorter than for central shutters, at the cost of some distortion of fast-moving subjects. Focal plane shutters have the advantage over central leaf shutters of allowing the use of interchangeable lenses without requiring a separate shutter for each lens. They have several disadvantages as well: distortion of fast-moving subjects. Although no part of the film is exposed for longer than the time set on the dial, one edge of the film is exposed an appreciable time after the other, so that a horizontally moving shutter will, for example, elongate or shorten the image of a car speeding in the same or the opposite direction to the shutter movement. They are noisier, which is a detriment to candid and nature photography. Their more complex mechanical structure causes a shorter lifespan than other shutter designs. If a focal plane shutter camera is left with sunlight falling on the lens, it is possible to burn a hole in the closed curtain of a non-metal shutter. Camera shake due to the impact of the larger curtain starting and stopping rapidly. Camera designers have learned to overcome SLR mirror slap by including a mirror lock-up feature in some cameras. This removes the camera shake from the large slapping mirror inside the camera, but does not prevent camera shake caused by the shutter mechanism itself. Mirror lock-up introduces yet another problem. With the mirror locked up out of the way, the optical viewfinder cannot be used for focusing, framing, or exposure metering. Newer DSLR cameras include a live preview, where the image from the main imaging sensor is displayed directly on an LCD display, so it is still possible to focus and frame. This prevents most camera shake from the focal plane shutter, as instead of a first curtain an electronic shutter is used. Simple leaf shutter. A simple leaf shutter is a type of camera shutter consisting of a mechanism with one or more pivoting metal leaves which normally does not allow light through the lens onto the film, but which when triggered opens the shutter by moving the leaves to uncover the lens for the required time to make an exposure, then shuts. Simple leaf shutters have a single leaf, or two leaves, which pivot so as to allow light through to the lens when triggered. If two leaves are used, they have curved edges to create a roughly circular aperture. They typically have only one shutter speed and are commonly found in basic cameras, including disposable cameras. Some have more than one speed. Shutters for newer digital cameras are a combination of electronic and mechanical timings. Some cameras employ a 100% electronic shutter, created by turning on and off the imaging sensor's signals. Digital cameras that can also take video implement this method for their video modes. For single-frame photography, then either mechanical or mechanical plus electronic methods are used. Diaphragm shutter. A diaphragm or leaf shutter consists of a number of thin blades which briefly uncover the camera aperture to make the exposure. The blades slide over each other in a way which creates a circular aperture which enlarges as quickly as possible to uncover the whole lens, stays open for the required time, then closes in the same way. The larger the number of blades, the more accurately circular is the aperture. Flash synchronization is easily achieved with a pair of contacts that close when the shutter is fully open. Ideally, the shutter opens instantaneously, remains open as long as required, and closes instantaneously. This is essentially the case at slower speeds, but as speeds approach their maximum, the shutter is far from fully open for a significant part of the exposure time. Effectively, the shutter acts as an additional aperture, and may, for example, cause vignetting or increase depth of field, undesirable if shallow focus is being used creatively. The term diaphragm shutter has also been used to describe an optical stop with a slit, near the focal plane of a moving film high-speed camera. A few types and makers of leaf shutters became very well known. The early compound shutter had a pneumatic mechanism, with a piston sliding against air resistance in a cylinder. They were quieter at slow speeds than clockwork, but potentially very inaccurate. More accurate clockwork mechanisms then replaced the air brake, and the German Compa, and the later Synchro Compa, became virtually the standard quality shutter. Later, the Japanese Copal shutter was widely adopted in quality equipment. The German Pronta and Japanese Seikosha shutters were also widely used. Up and Down with Compa, The Development and Photo-Historical Meaning of Leaf Shutters, by Klaus Eckerdres, translated by Robert Stoddard, gives a detailed history and technical description of leaf shutters. The company Compa Monitor was still in business as of 2012, but made only gas detection systems. Central shutter. A central shutter is not a type of shutter as such, but describes the position of the shutter. It is typically a leaf shutter, and located within the lens assembly where a relatively small opening allows light to cover the entire image. Leaf shutters can also be located behind, but near, the lens, allowing lens interchangeability. The alternative to a central or behind the lens shutter is a focal plane shutter. Interchangeable lens cameras with a central shutter within the lens body require that each lens has a shutter built into it. In practice, most cameras with interchangeable lenses use a single focal plane shutter in the camera body for all lenses, while cameras with a fixed lens use a central shutter. Many medium format and most large format cameras, however, have interchangeable lenses each fitted with a central shutter. A few interchangeable lens cameras have a behind-the-lens leaf shutter. Large format press cameras often had a focal plane shutter. Some had both a focal plane shutter and a lens with central shutter. One shutter would be locked open. Film cameras, but not digital cameras, with a central shutter and interchangeable lenses often have a secondary shutter or dark slide to cover the film and allow changing lens in mid-roll without fogging the film. The main advantages of central and behind-the-lens leaf shutters compared to a focal plane shutter are, relatively simple construction is possible. Less expensive to produce than a focal plane shutter. Flash synchronization is possible at all speeds because the shutter opens fully, unlike a focal plane shutter sliding a slit relatively slowly across the film for a short effective exposure. Small size is possible as the shutter is placed where the bundle of rays is narrow either inside or just behind the lens. Many versions have no connection between the cocking mechanism and the film advance mechanism, making multiple exposures possible. Usually much quieter. More realistic photographs in high-speed follow-through for lateral focal plane shutters compress or elongate the image in such cases. Longer shutter life. Some disadvantages of the central shutter are, for an interchangeable lens system, each lens has to have a shutter built into it. All leaf shutter speeds are limited by the speed at which the leaves can move, typically 1/500th of a second for a high-specification diaphragm shutter and 1/125th of a second for a simple leaf shutter. Some versions may have no connection between the cocking mechanism and the film advance mechanism, making accidental multiple exposures a common problem, although this is a feature of camera manufacture rather than the shutter itself. Electronic shutter. Digital image sensors can be constructed to give a shutter-equivalent function by transferring many pixel cell charges at one time to a paired shaded double called frame transfer shutter. If the full frame is transferred at one time, it is a global shutter. Often the shaded cells can independently be read, while the others are again collecting light. Extremely fast shutter operation is possible as there are no moving parts or any serialized data transfers. Global shutter can also be used for videos as a replacement for rotary disk shutters. Image sensors without a shaded full-frame double must use serialized data transfer of illuminated pixels called rolling shutter. A rolling shutter scans the image in a line-by-line fashion, so that different lines are exposed at different instants, as in a mechanical focal plane shutter, so that motion of either camera or subject will cause geometric distortions, such as skew or wobble. Shutter lag. Shutter lag is the time between the shutter release being pressed and the exposure started. While this delay was insignificant on most film and some digital cameras, many digital cameras have significant delay, which can be a problem with fast-moving subjects as in sports and other action photography. Release lag of a bridge camera such as the 2010 Pentax X90 is a relatively short 1/50th AS, or 21 milliseconds. The Canon 50D DSLR is spec-ed at 131 milliseconds lag. In many cases autofocus lag is the root cause of shutter lag. Lower-cost cameras and low-light or low-contrast situations will make the effect more pronounced, and it is in these cases that AF lag is more noticed. Most AF systems use contrast to determine focus. In situations where contrast is low, the speed at which the camera can determine the best focus can be quite noticeable. Since most modern cameras will not activate the shutter until autofocus is complete, the result is shutter lag. In these cases, the photographer can switch to manual focus to avoid the delay that is attributable to the AF function. Shutter cycle. A shutter cycle is the process of the shutter opening, closing, and resetting to where it is ready to open again. The life expectancy of a mechanical shutter is often expressed as a number of shutter cycles. Projector shutter. In movie projection, the shutter admits light from the lamphouse to illuminate the film across to the projection screen. To avoid flicker, A double-bladed rotary disc shutter admits light 2 times per frame of film. There are also some models which are triple-bladed, and thus admit light 3 times per frame. Shutters are also used simply to regulate pulses of light, with no film being used, as in a signal lamp. See also, photographic lens, Kerr cell shutter, active shutter 3D system, references, ABC up and down with compa, The Development and Photohistorical Meaning of Leaf Shutters, by Klaus Eckerdres, translated by Robert Stoddard, Sidney Ray, Scientific Photography and Applied Imaging, Oxford, Focal Press, 1999, Focal Encyclopedia of Photography, Macmillan, 1957, Compare Monitor website, Electronic Shuttering, Rolling versus Global Shutter Multi-NVIDIA Products, Shutter Operations for CCD and CMOS Image Sensors Kodak, http, www. Adorama Pentax unveils X90 Megazoom digital camera, http, Snapshot.com Canon EOS 50 DVS Canon EOS 60D